Good morning to all. This is Rajkumar from Karur VSB Engineering College. I am working assistant professor in civil engineering department, and I would like to share my knowledge about soil mechanics unit 2 portion. Let me see the topics now. So here the unit 2, the title is effective stress and permeability. So initially in this unit we discussed about what are the stresses in the soil water. So next one, what is the static pressure in water and effective stress concept. Effective stress concept means the developed stress due to the loading. If the saturated case means what is the effective stress, and the capillary phenomena and Targis law and the determination of coefficient of permeability, and the test, laboratory test as well as the field test. Laboratory test means constant head permeability and falling head permeability test is there, and field test means pumping out test by unconfined and confined aquifer. And next one thing is factors influencing the permeability of soil and seepage and two-dimensional flow, Laplace equations, and the introductions of flow net, and in which that determination of seepage loss and hydraulic gradient. So these are the topic we discussed in this unit. So let me see first topic. So initially we discussed about the core subjective. So from this unit, the students can able to understand the concept of stress transformations and flow through the soils. So this is a COPO mapping here. I just shown that. So for the second unit, that means CO2, which is mapped, highly mapped in the PO1 and 2 and 4 also. And the next thing is mediumly mapped in the PO3, 5 and 7 also. And it's a lowly mapped in 6, 8 and something 9, 10, 11, 12. So these are the POs are not mapped. So let me see the first topic here, soil water. So soil water means the water present in the voids of soil is called as a soil water. So generally it's divided into two types. One is a free water and another one is a held water. So free water means the water should be occupied by the influence of gravity. It is called as a free water, because the free water is only controlled by the gravitational forces. If it is the water is contains in the pores of soil without influence of gravitational forces, means that for water is called as a held water. So free water means the water is controlled by influence of gravity, and held water means the water cannot move under the influence of gravity. So the held water is furtherly divided into structural water and absorbed water, and next one is the capillary water. So the first thing is structural water. So in this case, the water should be chemically combined in the soil. It is not, it can't separated manually. At the high temperature around 300 degrees Celsius, only the water should be separated from the soil. So originally the soil and also the water should be together with chemically reaction. The next thing is adsorbed water. It is also known as a hydroscopic water. It is held by electrochemical forces existing on the soil surface. So normally the water should be absorbed from the atmosphere by the soil. So the entire water should be held in the pores of soil. So that soil is called as a adsorbed soil water. And this water also should be separated by the oven drying portions. Next thing is a capillary water. We know that capillary, so it is a permeable of soil. So when the water should be permeable, interstices of soil particle, and it should be held in particular portion, particular porous. That means it's called as a capillary water. So it exists in soil so long as that in the air. So capillary means the permeable. So when there is a permeable soil, the water should be accumulated by the capillary action. So next thing we discuss thing means static pressure in water. In normally the water has some pressure inside the soil particles. So the pressure should be developed by means of height. If should be the greater height means the pressure should be maximum. If the lesser height means the pressure should be minimum. So this is a major concept of the pressure. So initially we have to know about the pore water pressure. So the name itself it clearly denotes pore water pressure means the stress or pressure induced by the water in the pores of the soil particles. So that means pore water pressure. It is denoted by U. Generally U that is equal to gamma W into H. We know that gamma W is the unit weight of water and H is the datum height or the soil specimen height. So next thing that is total stresses. Total stresses means normally the soil which has created or which has produced some stresses due to the two major parameters. One is the self weight of soil and then second one is the overburden. So sulfate of soil that means gamma and overburden pressure that means gamma into D. So generally the total vertical stresses it consists of two major thing. One is a neutral or intermolecular stresses and another one is a pore water pressure. Pore water pressure. Okay, next one is a sigma that means total stress sigma equal to sigma dash plus U. That means effective stress plus neutral stress. Neutral stress also pore water pressure. And I denoted the formula itself here. Total stress that is equal to gamma into H. That means unit weight of soil into depth or height, whatever it may be. That means Z or H. Okay, so this is a total stress. And next thing, effective stress concept in soil. Normally effective stress is denoted by sigma dash. When the water is saturated by means of water means the stress is represented by the effective stress. So generally sigma dash equal to sigma minus U, where sigma equal to total stress and U equal to neutral stress. So effective stress is related to the total stress and pore water pressure or pore water stress. The next thing is a capillary phenomena. We already discussed about the capillary water. So capillary water means the water should be infiltrated or permeable in the soil pores by means of capillary action. So this type of rise of water above the water table by the function of surface tension. So surface tension normally it is denoted by T, capital T. So the formula becomes Hc equal to 2 times of surface tension because and normally the surface, the water surface has developed two sides. The two sides the surface tension will be act. So the 2 times of surface tension into cos theta divided by gamma W into R. So this is a formula to find out the capillary rise. That means it is a distance, that is a mm. Okay, so the height difference that is a hc that is equal to 2 times of t into cos theta divided by gamma W into R. Generally theta equal to that means the contact angle, otherwise the angle of interstices of soil, and gamma W we already noted that unit weight of water, and R equal to radius of soil pore. That means voids. The next thing is the Darcy's law. It is important thing one. Whenever we derive the permeability questions, first we have to know about the Darcy's law. So Darcy's law it should be only applicable for laminar flow and also in saturated soil. Laminar flow means it's the uniform velocity of water flow. Actually the laminar flow it should be assumed in the flow of water inside the soil particle. Generally the formula is small q, that means discharge. Otherwise it is a rate of flow that is equal to k into I into A. Normally the rate of flow, that means it is directly proportional to the hydraulic gradient. That is the main law of Darcy. So Darcy's law main thing, the statement is the rate of flow is directly proportional to the hydraulic gradient. So the proportionate constant, here the constant is a small k, that means called as a coefficient of permeability. Here I equal to hydraulic gradient, we discussed in later, and A equal to cross section of soil sample, that means cross sectional area. So next thing is the hydraulic gradient. So the I, it is find out by the ratio of level difference of water, that means level head, that means small h, divided by the length of soil sample. The water should be percolated or the water should be permeable. For example, I just kept one soil sample with a length of L, and I just connected the two level head difference of water pipe. One is a H1, the maximum height, and the another one is a H2 is a minimum height. So the level difference of H1 minus H2, that is called as a small h. So here there is a loss of head, and L equal to length of specimen. So from this experiment, the hydraulic gradient, that means I, it is derived from H by L. Okay, the next thing is the determination of laboratory determination of permeability. Normally the permeability is also known as hydraulic conductivity. The coefficient of hydraulic conductivity is determined by the two methods. One is the constant head permeability test and another one is the falling head permeability test. In both the cases we have to find out the coefficient of permeability, that means small k value. So based on that the type of soil should be identified, because each type of soil has different value of permeability. So the first thing we discussed about the constant head permeability test. So in this case, the constant head permeability test means the soil sample should be connected the two tanks. One is a upper tank and another one is a lower or bottom tank. So the two tanks has a different level of water. So from these two tanks, the water should be percolated in between of soil sample. So based on that we have noted the level difference H1 minus H2 based on the time differences. At the time interval T1 and T2 we get it the H1 and H2. So based on that we calculate the coefficient of permeability. The next thing is falling head permeability test. So in this test the level difference, that means H1 and H2 should be variable with respect to time. But before that the constant head means the namely is clearly denotes the head difference is mainly it's a constant all over the experiments. But here falling head permeability test, the constant head should be variable based on the time. So for the time T1 the H1 should be variable and the time T2 the H2 it should be variable. So from this we get it the H1 and H2, and finally we find out the coefficient of permeability. So next one, what are the factors to be considered for the permeability of soil? The first thing is grain size. For example, if the grain size should be maximum means the void should be accumulated by more. So by this way the water should be easily percolate into the soil. So the permeability or coefficient of permeability will be more. So void ratio, that is also same thing case. If it has a more void ratio, that means E max means the void should be maximum means the water easily percolate into the soil, so that it has a coefficient of permeability value also high. And next one is the soil structures. So based on the soil structures also the permeability should be differ. Monomer or otherwise some type of clay particles means the permeability will be very low. So for the particular cases, the permeability coefficient will be very less. Next thing is the degree of saturation, because in clearly I denoted that the Darcy's law is only applicable for saturated soil. So because of that, if the degree of saturation will be more, means for fully saturated soil, that means S value 100% means there is no water should be permitted to permeable. So if the degree of saturation is minimum means the water easily percolate into the soil and the permeability also will have. The next thing is the temperature of water. If it is a high temperature of water means the density will be low, so this will be easily percolate. Otherwise, if the temperature low means the density will be high, so because of density of water, the percolation also will be less. So these are the factors influencing permeability. So next thing is a seepage. So normally seepage is called as a flow ability of water inside the soil particles from one datum to another datum. You just take it some example of dam. So upstream level is maximum, downstream level is minimum. We already know that. So for the level difference, the water trying to move and trying to catch up the same level. So the pressure should be induced at the bottom of dam. So the water should be percolated at the basement. So this scenario is called as a seepage. It is a flow of water through the soil pores because of some level difference. So it occurs under the hydraulic gradient. So it mainly caused by the uplift pressure or other is a piping failure. So let me see about the two-dimensional flow here. So normally the flow pattern, the seepage flow pattern has two lines. One is the EQ potential lines and another one is the flow lines. These both lines are controlled by some equation. That equation is called as a Laplace equation. So that only I clearly denoted here. Flow occurs in the two directions and it's seen in the earth dams and sheet pile walls, and it analyzing using by the flow nets. So this is the Laplace equation. We already denoted that Laplace equation, that is dou square h by dou x square plus dou square h by dou y square, that is equal to 0. That means the same EQ potential lines as well as the flow lines have same pattern at the each flow. So it is only applicable for homogeneous and isotrophic soil, and also it should be factored by the steady seepage also. The next thing is a flow net. So flow net, it is a graphical portion graphical representation of two lines, that means EQ potential lines and flow lines. It is also used to find out the quantity of seepage as well as the uplift pressure, because it is only used for the design of dams as well as the retaining wall. So before constructing the dam or before constructing the retaining wall or any water retaining the structure, first we have to know about the seepage. So what is the pressure induced in the soil by the water, and what is the hydraulic gradient. So based on that only we have to derive the quantity of seepage at the bottom. So only we have to produce some basement. Okay, next thing is a course outcome. So from this unit we clearly understood the what are the stresses developed in the soil. That means total stress and neutral stress and effective stress. So normally sigma equal to sigma dash plus u. The next thing, how to find out the pore water pressure as well as total pressure. Normally pore water pressure, that means u, that is equal to gamma w into hw, and total pressure or total stress, that is equal to gamma into d. So from these two parameters we easily calculate the effective stress. So in the effective stress concept, so the effective stress at each layer of soil should be differ. So initially at the ground surface it should be 0, and the bottom surface it should be maximum. And the next thing we discussed in this unit, that is permeability. So what is the term of permeability? So what is the Tarski's law, and what are the main functions of a hydraulic gradient? So the next thing is important thing one, how to find out the coefficient of permeability. That means two tests are there. One is a constant head permeability test and a falling head permeability test, and as well as the pumping out test also carried by in the field. So that means unconfined aquifer and a confined aquifer, the pumping test are carried, and also the coefficient of permeability should be find out. And next thing we discussed, that means the two-dimensional flow as well as the Laplace equation, also the flow net. So I understood everyone has a clear concept about what are the effective stresses present in the soil and what is the permeability concept in the soil. Okay, thank you so much.